The smart era isn't coming, it's upon us already. And in a world where terms like cryptocurrency and blockchain roll off the tongue of even the least techie amongst us, what does that mean for the future of work, life, and finance? It's still something of a mystery. So, here to encourage us to embrace the blockchain revolution, in conversation with Bradley Tusk of Tusk Ventures, please welcome one of tech's greatest pioneers, Stephen Wolfram.
Okay, thanks so much for joining us. Got a short amount of time, so I'm going to jump right in. So, Stephen, you're one of the few people I've seen so far who can cogently explain blockchain in pretty plain English, at least based on what I've read of what you've written. So, kind of three questions around that. One, why do you think this is a concept that's been pretty hard for people to conceptualize? Two, how problematic is it or not that most people can't distinguish between cryptocurrency and blockchain? And three, does blockchain need to be well understood to be successful in society, or does that not really matter?
So I think there's worth understanding there's several different concepts that have all gotten rolled together. I mean, the fundamental idea of blockchain, it's all about making, a ledger that can't be tampered with and so on. I remember like when I was a consultant at Bell Labs back in the early 80s, they used to have this thing where they would take a bunch of the data from things like lab notebooks, I think, and they would make a hash of it every week, and they would publish the hash in the New York Times. And you could be pretty sure that, by the time the hash is in the New York Times, there's no way that can be tampered with. And that's a pretty good scheme. It doesn't allow you to go back, as blockchain does, and actually inspect the previous transactions, with a computation and so on. But that's the first thing, is kind of the ledgering capability. The second thing, which kind of came about with Ethereum and so on, is this idea of smart contracts, the idea of having something where there's a computation that goes on that relates to transactions. I think that's an important idea, but it's worth realizing that's not a blockchain-related idea. That's an idea about whether you can take the kinds of things that are in contracts and turn them into something that can be represented computationally. That is, right now we have lots of kinds of contracts that determine how things work in the world, and we write them out in English or in legalese or whatever else. The question is, can we write them in code? Can we write them in a language that humans can understand and that machines can also automatically execute? And I think to me, that's really the bigger story here, is computational contracts and being able to take all these things that right now are run as a very human process and turn them into something that can be run as a computational process. And I myself have been involved in building our Wolfram language technology stack for the last 30 years. And one of the features of that is that it's a language, kind of the only one, that can sort of express things about the real world. So I've gotten pretty interested in this question of, can we express the kinds of things that we find in contracts, both the operational clauses in contracts, do this and so on, and the non-operational clauses about, what the circumstances and so on are. Can we express those in some kind of, in the form of code? And what do things look like when we are running, when a lot of the kinds of transactions that happen through contracts happen computationally like this? I mean, just to finish the thing about blockchain, the other thing that then that leads to is this idea of, okay, so we've had various different venues for computation. We have computation on our desktop computers, we have computation in the cloud, on mobile, and so on. I think with computational contracts and with sort of the general idea of blockchain, there's another venue for computation, which is kind of autonomous computation. That is, you have a contract and you say, when this happens in the world, I want this to happen. And you just lodge that lump of computation somewhere in the kind of computational infrastructure of the world and expect that it will be executed that way. And that's kind of a thing which, again, it relates to the blockchain idea. It's not specific to the sort of, the specific concepts of blockchain and all the details of how blockchain works, but it's kind of something that emerges from the general idea of having kind of ambient computation where you just lodge this lump of computation somewhere and it will magically be executed when it's needed.
Right. So in terms of it succeeding societally, does it need to be then understood, or ultimately people just accept that it can do what it's supposed to do, and as long as it sort of delivers, it doesn't really matter?
My point of view about sort of understanding stuff, it's understanding what one might call computational thinking about kind of so my version of this would be, what is computational thinking? It's about being able to take some idea that you have and communicate it to a sufficiently smart computer. The details of how the computer works inside, the details of how your car engine works, whatever, it's not so important. What's important is to know, what does it mean when you're driving your car, so to speak. And I think in this case, it's the same kind of thing, that understanding the kind of computational concepts around this, that's important. Understanding the details of what particular hashing scheme is used here or there doesn't really matter. Leave that, that's the job of the engineers, so to speak, to try and get that kind of thing right.
How much do you think the regulators have to understand at least some of this so that smart contracts can be legally valid? Because you can create all the computationally, but ultimately there's a legal system that has to be in place as well.
Right. So my point of view about computational contracts is there are different levels of sort of size of contract. So if you're doing a thing that's, some weather insurance for $50, or you've got some contract that says, so a typical kind of computational contract, here's an example, I don't know, let's say a snow plowing contract. So you're going to say, if it snows and it's a weekday, then you're going to plow out this parking lot, and if you plow it out within a certain number of hours, you'll get paid $100, whatever it is, right? So what does that actually turn into? It turns into a piece of code that includes things like this webcam somewhere will be watching the parking lot. You have to know something about whether it's snowing. You have to know that from weather feed. You know something about, you're looking at the parking lot with a machine vision system. You're deciding, did it get plowed out? If it did, then eventually you pay the person $100 or not, as the case may be. Now, those kinds of contracts, which are for fairly small amounts of money, I don't think blockchain doesn't really contribute to that. What's important there is, can you express that contract computationally in such a way that a machine somewhere in the cloud, somewhere in the computational infrastructure of the world, can just execute that contract without any human having to go out and look. Did the parking lot get plowed? Was it really snowing, et cetera, et cetera, et cetera. So that's sort of one level, is the low-cost stuff. I think you kind of just get to, trust the cloud providers in a sense to do those kinds of things. Then there are the very high-cost things, where $10 million is moving from here to there. And I don't think people want that to be anchored in kind of the weightiest stuff that we have in the world, which tends to be things with governments and legal systems and insurance companies and so on. And I think that's a sort of a different level of what's going on. I think there's an intermediate level where anchoring things on either private or public blockchains is interesting. I don't know exactly where that domain, I don't know exactly what the dollar amounts where that becomes, oh yes, this is really worthwhile to put on the public blockchain, where right now the transaction costs are fairly high, or on some private blockchain, between some group of entities or something. But I think that's where that lies. And I think this question about sort of how this works, from a regulation point of view, I know nothing about politics. That's your domain. But in terms of things like, should people be allowed to buy and sell cryptocurrency as they please? It's kind of like you have to decide how much is the state going to sort of help people to avoid their own silliness or whatever. And that's not I don't know the right answer to that.
State's usually not that good at it.
I think that in terms of people's understanding of, I think this idea of computational contracts and what it takes to have a legal system work with computational contracts, that's pretty interesting. And I know we've interacted with some smaller but prominent countries that are interested in how do they adapt their legal systems so that, frankly, so they become the venue of choice for people who are executing those kinds of contracts. And I think that's interesting. And there will be, things like, two parties might agree, we're going to use this machine learning classifier to decide whether these goods that you delivered are rotten or not, right? And then they decide, they say, here's the classifier, we've all agreed it has certain training input. Now the contract just says, this will be how we decide this. So, I think that's, and there are sort of levels of understanding what all of that means that one has to go through, and that seems very worthwhile.
Right. So, contract seems like an obvious application for blockchain, something that can obviously do a lot of good. What else excites you in the space?
Well, I think, the main issue with, a lot of what's going on here has to do with kind of how do you do transactions in the world, so to speak. Yeah. Some of it has to do with how do you store information about the world. An example would be there are lots of things which people have as personal data, whether they're their Facebook data or which presumably is personal data. I don't know. Back in 2012, we did this big project where we let people connect from Wolfram Alpha to their Facebook profiles, and we showed them. We generated the 50-page book of what you could learn about yourself and your friends from Facebook. One of the common responses, a lot of people did it, and one of the common responses was, "My gosh, Facebook knows so much about us." There's data like that. There's potentially health data, medical data, things like this, where one can imagine situations where people are more freely uploading that to some kind of encrypted, public arena. Frankly, it's not an easy problem to take, data that's been uploaded and figure out how to get reasonable aggregated conclusions from it. I mean, it's easy to realize that if we had everybody's medical data, then there will be a lot of useful conclusions that could be drawn from looking at people's, looking at the sort of the general results from people's medical data. But on the other hand, one doesn't want to be able to drill in and find the particulars of one particular person's medical information. Right. And it's a really hard problem to know how to, and I think it's a theoretically unsolvable problem, actually. And I think it's at some level like a computer security problem. That is, you can do things like you say, well, people can only look at this aggregated data. Okay, let's say 5 different groups look at aggregated data and they collude. Then you end up being able to sort of slice down between those different colluded things. And in the end, it's really a hard problem. I mean, the Census Bureau has tried to solve some of these problems for a long time. And there's sort of limits on what they have released as a result of that.
Do you think it's an unsolvable problem, or is it just a really hard policy choice that politicians don't want to make? I mean, they could theoretically say, you have less privacy. We live in a world right now where for things to be done efficiently and for us to take advantage of all the different opportunities out there, people have to live with less privacy, and that's that. Politically, obviously, that doesn't poll really well at all, but would that not solve the problem?
Yeah, I mean, look, in different countries, there's different degrees of concern about, health records and things like that. And yes, that's, I'm not sure I would be thrilled to see that happen, but, that's certainly something, if can we solve the problem mathematically? Probably not. Right. When you talk about policy and so on, I mean, I think one of the interesting and computational contracts, one of the really curious things is when we think about AI and so on, and we think about, okay, we want to somehow control something about how AIs work. Like, for example, we'd probably like to have a situation where, AIs are nice to humans, right? Yep. So the question is, so let's imagine that into every AI system, we could build sort of an ethics box that said, be nice to humans. The question is, what on earth would that actually be like? Right. And I think our best sort of trial run of that is building computational contracts that represent things. And what I think we'll discover is people kind of have this belief that there's going to be a magic set of, Asimov's 3 laws of robotics or something that will determine, what you need to be able to tell the AIs to make sure that they're being nice to humans. I think for theoretical reasons, actually, as well as practical ones, that will never work. In other words, the world is too complicated a place, and what one will end up with is a sort of code of laws that is effectively as complicated as human law is right now. Right. Albeit encoded in a computational form so the AIs can kind of understand it. Now, obviously, a big sort of policy issue is, okay, what should the constitution for the AIs actually be like? Right. What do we want to, tell the AIs about what they should do and not?
So if you were writing the AI constitution, I said, give me the 3 amendments, the Bill of Rights, what would they be?
I don't know. I haven't, see, this is where I'm a technologist, kind of scientist, something like that. Yeah. The thing that I was curious, like, for example, here's an issue. So you write the AI constitution, and you say, I don't want the AIs to ever change this constitution, so I've got to burn it in somehow. Right. But then you realize, oh my gosh, if we burn in the constitution in 2019 or something, and it's fixed for all time, that's not really a good story, because then the whole future of humanity is locked.
Based on our wisdom right now, which these days seems pretty specious.
Well, yes. So I was curious. I looked at the constitutions of different countries around the world. There are 3 categories of things they say. Either there'll be a super democracy that's going to be able to change this constitution, or there's some kind of supreme leader somewhere who's just going to decide it, or particularly in some post-Soviet ones, this was characteristic. The thing is so complicated, forming committees of committees of committees, that it wasn't clear, from a sort of mathematical point of view, it might be undecidable whether you could ever get to the end of this and actually update your constitution. But I think, that's an example of a thing that one has to try to address. But I think the main thing we see as we turn kind of ethics into code or whatever is, we have to actually be clear. I've often been involved in things where it's kind of a big philosophy discussion for a long time, and then in the end, it's like, okay, now we actually have to write code. Yeah. And at that point, you have to really decide what you want, because, it's going to be there in code. And I think this is now really a reflection on what we want humanity to be like and to be about, is, what we do in this. I have to say, in the area of cryptocurrency, I'm really amused by one sort of philosophy to reality transition that I've noticed. So back in the early 1980s, I was very big on a concept called computational irreducibility, which is kind of this idea that there are, in science in general, you are all about prediction and being able to figure out, some formula for, where the Earth will be a million years from now, and you just get the answer. But there are a lot of systems where you have instead computational irreducibility, where you kind of have to follow each step of the evolution to be able to work out what will happen. So I thought about this as an interesting thing in science. It's interesting in philosophy. It has to do with the nature of free will and things like this. I thought, great theoretical thing, okay? Then Bitcoin comes out. And then I realized that this proof of work process for Bitcoin is kind of grinding against computational irreducibility. It's using computational irreducibility to build something that has some kind of irreducible value. And I have to say that the transition from kind of the philosophical idea to the person, goes to Shenzhen, picks up a crate of computers and takes them to Iceland and runs this computationally irreducible computation is really quite disorienting for somebody like me.
Is it disorienting but sort of demonstrates progress, or disorienting and demonstrates dystopia?
It's really hilarious for me, frankly. I mean, it's like, it's that something which is the sort of that, it's always, honestly, it's always interesting when these sort of fundamental ideas end up actually hitting reality in the world, and sort of how that happens is always an interesting thing. I mean, I think, and right now, this whole question about, will cryptocurrency be the future of money and so on, that's another area I'm curious about. I think my feeling is the only way it really works is if there's real economic activity that connects to this cryptocurrency stuff. And I think my current view, which might change, is that this whole computational contract business is the key to making this really work. And if that really takes off, which I think it will, then trillions of dollars will flow through computational contracts, and having some easy-to-use cryptocurrency that kind of connects to these things, that will be worthwhile, and that will support valuations for cryptocurrencies that are meaningful, as opposed to something where it looks like kind of a big speculative bubble, so to speak.
Right, absolutely. All right, well, they told me not to ask any questions once we're past 30 seconds to go, so thank you very much for doing this. Thanks everyone for attending, and we'll see you again soon.
Great.